Welcome back, everybody, to episode 2 of our video stream in which we program an entire video game from scratch. So in episode 1, we did a little bit of an introduction. Let's go ahead and relaunch this solution here. Let's go back in here. I introduced you to Visual Studio, and we wrote essentially the most basic C program that you can write. So now it's time to start turning this into a little bit more advanced. We want to eventually convert this from a console program into a Windows Win32 GUI application. But first, I want to go ahead and get a housekeeping thing out of the way. It's something that I always do. If you go to the properties of your project, the first thing I like to do is I always like to fix up these output directories, and I just like to make them consistent. So I'm going to copy that. So you can see how it applies only to release and x64 right now. But if I go to all configurations, all platforms, see how it says different options? I don't want that to be different options. I want that to be the same option across all platforms and all architectures, all configurations. It's just, you don't have to do it. It's just something I like to do. And by output directories, what I mean is this is where Visual Studio will spit out your compiled executable. So basically, I'm just going to put it here. The intermediate directory can go there, and that's it. And hit apply. All right, let's go through the rest of these and see if there's anything else that needs changing. All right, now last time I know we touched a bit on the difference between Ascii and Unicode. Ascii is also known as multi-byte in this context. But we need to make an important decision right now, and that decision is: are we going to compile? Are we going to use Unicode, or are we going to use Ascii in our program, in our game? So we kind of have to pick one or the other. You don't have to, but for best practice reasons, it's good to stay consistent, right? You might as well use one or the other. Given that I told you about the performance penalties for using Ascii in the context of the Windows API, that gives us a good argument for using Unicode. However, the Ascii programming with ASCII character set is typically cleaner because you don't have to write little L's, and you can use all of the narrow versions of functions like str copy instead of WCS CPY. Every time you use a Unicode, every time you use a function against a Unicode string, it typically needs to be a different version of the function. There's a special set of functions for Unicode strings versus ASCII strings. That being said, you can't represent very many characters with ASCII, so like if we ever came across the need to represent like some sort of like kanji character, some sort of Japanese thing, or something with an accent mark or tilde over it, we wouldn't be able to do it with ASCII. You would need Unicode typically. So I'm just going to make a decision. I'm just going to make a decision. I honestly don't know which I'm going to do. Since this is our first program ever, I'm going to go with multi-byte character set. I'm going to do the simpler ASCII character set because I figured I don't want to get into Unicode, since this is our first program. So, all right, that decision has been made. Next one is whole program optimization. I think I showed you this last time. If you select, I'm going to go back here, select all platforms. If I select debug, then it's turned off. If I select release, then it's turned on, etc. Let's move on. We don't need any of those yet. We don't need to mess with any of those yet. Now this little section, C/C++, it's worth noting that this little section of your properties doesn't show up until you have actually added your first C or C++ file. So if you're wondering, if you're opening up these pages on a blank empty project and you're like, where's the C++ section? Just keep in mind it doesn't show up until after you've added your first source code file, which we did last time in the main.c. So let's go through here. Okay, so this one is really important. The warning level. This is essentially how pedantic is the compiler going to be when analyzing your source code. Sometimes there are you might have syntax errors, or you might be doing something that by the C specification, by the rules of the C language, is illegal, and therefore that will generate a hard error and you can't compile your program. But sometimes you will program in such a way that it's not necessarily an error, and your program will still compile, but the IDE, the compiler, still detects that there's something about it that is fishy, that is suboptimal, that is potentially dangerous, and it will warn you about these sorts of things. So you could still compile even without, even with the presence, even in the presence of those warnings, your program may still run fine. But the warning is warning you against something that is potentially something that you need to look at. So the warning level is just how aggressive do you want that to be? Like, should I warn you about every little potentially meaningless thing, or should I only warn you about the important things? So something that level 3, warning level 3 is the default. Honestly, I like to put it on all warnings. So I think that's probably what we're going to do. And I think there's a problem with enabling all warnings, is that the compiler becomes so pedantic that it warns you about every little nitpick, every little thing that it detects might be a problem, even though it's not really a problem. The good thing about that, though, is that it encourages you to learn about all of those potential issues. Like, what do they mean? Why is it warning me about this kind of things? How could it possibly be an issue? It's just, there is another issue. There is another problem with enabling all warnings, and it's that a lot of the code. Do you want to save it? Yeah, I clicked off that. I'm going to hit yes to save the changes. And I was going to say another problem with enabling all warnings is that all of this other stuff, all of this other code that we do not control, for example, all of the stuff in Windows.h actually generates warnings at this all warnings level. The Windows.h header file, which is not ours, we didn't write it, Microsoft wrote it, but it doesn't compile cleanly without errors unless you turn the warning level down. So we will figure out how to suppress those errors in like files that we don't control. But I still like, for our own code, the code that we write, I still like to have it run, all warnings. So let's see. Let's go back to the properties. We're not done here. Alright, so I enabled all warnings. Don't need anything else here. There's optimization. These are more of these settings that will change depending on whether you're on release or debug. Now see, I messed up there because I had it on release, so I only changed it to enable all warnings if I was using the release configuration. I forgot to set it back to all configurations. Okay, back here we have these optimization things. The defaults are typically fine. Don't have to mess with them. Don't need any of these. Code generation. So if I set this to debug. Okay, the most important thing here, the most relevant thing in here is this setting right here, Runtime Library. If you set this, well, here are the options. There's 4 options: multi-threaded, multi-threaded debug, multi-threaded DLL, and multi-threaded debug DLL. So the difference here is if you are, okay, we're going to just talk about the debug configuration first. So the 2 things for the debug configuration are multi-threaded debug and multi-threaded debug DLL. Basically what that means is if you choose the multi-threaded debug DLL option, it takes this huge chunk of universal C runtime library stuff and separates that into a separate DLL file. And what that means is that your executable, your exe file, will be much smaller, but it will be linked against this external DLL file. In contrast, if I choose multi-threaded debug, then it generates the executable and it takes all of that C library stuff and embeds it into the executable itself. So the executable is much larger, but it's also more portable, because if I want to give that executable to someone else, if I want to save it to a USB stick and give it to someone else, I can just put the executable on there itself by itself, and I don't have to remember to also bring over that DLL file as well. Let me show you what I mean. I'll go ahead and first I'll do multi-threaded debug DLL, and I'll hit OK, and I'll build. Now, for now, ignore all these warnings. These are all warnings coming from the Windows.h header file that we didn't write, and we can't even really do anything about it right now. So just ignore them right now. What we're doing right now is working on debug. Let's see. Oh, sorry. So this is x64. Now, this is why I modified those output directories, because I hate how this is inconsistent. Like, I have a debug folder here, and then I also have a debug folder underneath the x64 folder. I don't like that, the way it does that. But anyway, okay. GameB.exe, 57 kilobytes. If I look for, there's a DLL file. If I were to take this, let's see, and put it, I don't know where the DLL file is. It's probably in Windows System 32 or something. Or maybe in the Visual Studio install directory, somewhere in there. But the point is that if I took this executable, this 57 kilobyte executable, and I gave it to someone else, and they didn't have the same DLL file installed, then it would give them an error about it not being found. Let's see here. Okay, if I go back to the properties of my project and I change this to multi-threaded debug, okay, and rebuild it. What I have now look at, I have the same GameB.exe. It's now over 1 megabyte. It's over 1,000 kilobytes. And the reason why is because it took that DLL file that you need for just basic compatibility with the Windows operating system, and it baked that into the executable and embedded that into the executable. I prefer it this way because, like I said, I prefer the portability over, sheer size. I suppose if we were trying to pack this onto like one of those 1.4 megabyte floppy disks, like it was 1995 all over again, then the size of the executable might matter. But to me right now, the size of the executable doesn't matter. So I prefer the portability of just having the runtime library baked into the executable file. So I'm going to go over here. I'm going to change. I also need to change this option for the release configuration to multi-threaded. Wait. Release multi-threaded. Yeah, that's right. Okay, so the release runtime library is multi-threaded, and the debug runtime library is multi-threaded debug. So all that's correct. And if I go to all configurations, it's set to different options. Okay, so I think none of this other stuff really matters to me right now. All options, etc., etc. Oh, I should, yeah, so all of this stuff actually translates, all of these options that we just configured is actually translated into a command line. You can do all of this, you can automate all of this compilation over the command line. This IDE, this Visual Studio IDE, is just a convenient graphical way of automating this compile process and linking process. Let's move on to the linker options. I don't think I care about any of this stuff yet. Debugging, yeah, if you want to generate debug information that's useful. Right now the linker is set for the console subsystem. Do you remember in the last video when I told you about the different types of programs that you could write for Windows? You have console apps, and you have Win32 apps. So I have Windows, native, EFI, boot ROM, POSIX. I'm just going to leave it on console for right now. That will come in handy later, but we'll just leave it on console for now. All this other stuff, yeah, not important right now. So I'm just going to hit OK. And I'm also going to delete all that. We can rebuild it. Okay. So let's do some coding. So I want to convert this into a Windows app, which basically means the first thing I need to do is I need to change our main function, our int main. I need to convert that into the Windows version of the main function, which is WinMain. Every Windows program, calc.exe, notepad.exe, every Windows program starts with WinMain the same way that all console programs start with main. So WinMain has an interesting syntax. Let's just go ahead and look it up. There is no shame in looking all this stuff up off of the internet. You don't have to memorize everything. And there we go. No, okay, so I'm back here on MSDN, formerly known as MSDN. Now it's docs.microsoft.com. And this is documentation that tells you all about the WinMain entry point. There's one other weird thing I wanted to show you. This is an empty WinMain example, and we're going to copy this and we're going to paste it into our project. But I also wanted to show you, if you look up top, notice up here there's actually a W WinMain. It's the wide Unicode version of WinMain. I don't think you should ever use it, and I think if you read all these comments, it'll tell you it's like a vestigial thing. There's no reason to use it anymore. Just use regular WinMain, regardless of whether you're building ASCII or Unicode. I'm just going to paste that in. I'm going to delete our old stuff. I'm going to convert this to parentheses because I told you I like the parentheses. There. Now we've converted our function into WinMain. So there are some things that I don't like about this. I guess I'll leave it for now. But as before, you can see like this is green int in all capital letters. You can see it's actually type deft to the built-in integer type. It's just the way the Windows API likes to do things. Like, it literally doesn't matter if I could do that. It works the same way. It's the exact same. So this is a handle. and a handle is essentially a memory address. Remember from last time, this is the same as the main function. These are input parameters that are put into the main function from the operating system. So this is a handle to the instance of this program. And we actually are going to end up using this at some point. This next parameter, this second parameter, is a handle to the instance of previous instance. And I think if you read the documentation on WinMain, it'll tell you that that is really old, left over, and no one uses that anymore. So we'll probably never use that. This is PSTR, and you can see that it's type def to a char star PSTR. It's essentially a pointer. That's what the P stands for. It's a pointer to a string, and the variable is called command line. Long pointer to a command line. So these are the command line arguments, or this is actually the entire command line, including all of the arguments that were used to start this application. I wonder if I have Process Explorer configured here. I do. So if I look on my system, this is sysinternal's Process Explorer. You can see that each one of these processes that is running on my machine has an associated command line, and it may have, like these guys may have lots of command line arguments, and that's what you'll see inside this variable right here. And this command show, I don't know what it's for, but we won't be using it. If you really want to know, you can look it up. I think it might have something to do with like whether it starts whether the window starts minimized or maximized or something like that. All right, I can't stand it. I gotta look it up. Okay, there it is. It's a flag that says whether the main application window will be minimized, maximized, or shown normally. So, you might use that. So let me go ahead and build this and see what happens. Okay, I had to go build, rebuild solution, and when that happened, it actually didn't work. I got 2 errors. You see the errors right there? We're going to disable the warnings for right now, because we have so many warnings because we left it on enable all warnings, and all those warnings are not important. We'll get to those later. But the errors are actually preventing us from compiling this executable. So what is it saying? Unresolved external symbol main referenced in function int underscore c decal, etc., etc. Okay, so whenever you get these error messages that say unresolved external symbol and unresolved symbols, it's coming from the linker, and you can also tell that based on this error code. See, it starts with LNK. It's a linker error, and in basic terms, what it's telling you is that you are using a name of a function that the linker doesn't know where it is. It can't find it, and it's this WinMain. It's because we switched from main to WinMain without telling the linker, oh, by the way, we have now switched from making a console program to a Windows program. So I need to go back to properties of my project. I need to go back to the linker. There we go. And I need to go all configurations, all platforms, and I need to change the subsystem from console to Windows. There. Now, I'm going to try it again. Build succeeded, no errors. So we've converted our main function over to a Windows program from console program. Okay, so let's do something about all these warnings. What we could do is we could tell the compiler. These are called, okay, I'm going to type pragma warning. No. pragma warning pop. Okay. So let me explain this. This pound sign pragma. These are called pre-compiler directives. These statements, these aren't actually code that will go into your executable. They are just, we are talking directly to the compiler and we're telling it to behave in a certain way. We're telling the compiler to behave in a certain way, not necessarily our source code. So what I mean by that is I'm saying, and there are lots of many different types. This is just one type that is used to adjust the warning levels from within your code. So you can actually adjust your warning levels in your source code file without having to go to the properties of your project like we have been doing. So what I'm saying is I'm telling the compiler, take the current warning level and I want you to basically save the previous warning level, but make the current warning level a 0, which means disable all warnings. Then I want you to include windows.h, which remember, like I said last time, the pound include is basically saying I want you to take that .h file and just copy paste it directly into our source code file. So it literally is just an expansion of the entire contents of this windows.h file. And if you really want to know, you can right click on windows.h file and you can view code something. I don't know. You should be able to open these and look at them. It's just a file on the disk. Peak header. Is that what it is? No. It doesn't want to let me do it. I don't know why. It's somewhere on my hard drive in the Visual Studio. You can usually find a copy of it like on either GitHub or what's the other one where you post little snippets? Pastebin. You can usually find copies of it on there. People trading exploits and stuff. Anyway. Okay, so let's go back here. Anyway, so this is a whole file that got included in there. And what it's saying is I don't want any warnings to apply whenever you are including this windows.h file because all of our warnings originate from that file. Then once we get done including the windows.h file, then I want you to pop out the current warning level of 0 and I want you to reinstate the previous warning level, which was enable all warnings. So we're basically temporarily disabling warnings while we include windows.h, and then we're coming back to enable all warnings. So if I build again, now we only have 4 warnings, and these warnings only apply to our source code. And they're basically, they say unreferenced formal parameters. This is what these are called, formal parameters. The parameters that are listed here in the function definition, input parameters. If we wanted to get rid of these warnings and tell the compiler that we're not going to use these, well, I mean, you could actually use them. You could say, handle z equals h instance. And if I recompile, the warning about h instance has gone away because now I am referencing it, but I also created a new variable z. Local variable is initialized but not referenced. So the compiler is keeping me very clean and tidy when I keep all the warnings enabled, and that's why I like to enable all the warnings. So let's erase that. Let's just go unreferenced parameter. This is a macro h instance. Unreferenced parameter h3 instance. Unreferenced. finally unreferenced parameter in command show. Recompile, and there we go. Now we're back to compiling with 0 errors and 0 warnings. We essentially just told the compiler, yes, I'm not using those variables on purpose. So that way the compiler doesn't say, hey, did you forget that you have a variable here that you're not referencing? Yeah, we're doing that on purpose. Let's see, a couple more things. In C++, did you know in C++ you can actually omit the names of the formal parameters completely if you don't intend to use them. You could have it just like that. And you're basically just telling the compiler, I'm not going to use these formal parameters, so I don't even have to name them. All you need to know is this is how much memory they take up. You still need to know the footprint of these parameters that are going to be coming into you, but you don't need to supply the names because we're not going to be using the names of these variables because they're unreferenced. We're not going to use them. Can't do that, however, in C, at least not in C89 like how we're programming here. You do have to name them. That's actually a trick that I was on Twitter and I saw a tweet from John Carmack saying that, oh, he just now learned this, and I thought it was cool that just for a moment, just for a fleeting moment, I knew something that John Carmack didn't know. But anyway, so there's one other thing. I don't like the way these variables are named. This is a certain type of syntax, a certain type of naming convention where we sort of try to give a clue as to what data type the variable is based on its name. See how H instance starts with an H, the name of the variable starts with an H, and it's supposed to clue people in that, hey, this is a handle, as opposed to, hey, this is a D word, or this is a string, etc. I don't like that. I think it's something that people used to do back in the 80s and 90s, and it's just not really necessary anymore. So I'm going to change it. Instead of H instance, I'm just going to say instance. Instead of H prev instance, I'm just going to make it previous instance. Instead of LP, which stands for long pointer, instead of long pointer to a command line, I'm just going to write command line. And instead of in command show, I'm just going to make it command show. I think the other reason that people used to do it like that is because, well, something that you'll notice is that I always like to spell out the whole name of the variable. I like to be more verbose, and I think that's because a long time ago, monitors used to be much smaller. People used to program on 640 by 480 monitors, or sometimes even smaller. You know, if you go way back, a monitor used to just be monochrome, and you could only fit 80 characters of text on each line. That's why programmers grew up to they grew accustomed to shortening everything and abbreviating everything. But nowadays in the year 2020, we have huge monitors. I can fit lots of stuff on a line. So I'm just going to make the variables more verbose. That way you don't have to think about what the abbreviations mean. I have to update all these unreferenced parameters. Okay. All right. It is time to get on with the show now. We need to start making I want to make a window, and I think we can do this with the rest of the time that we have today. So when you're making a Windows Win32 program, and they call it Win32, this will help you when you're Googling for stuff, because even though we're running a 64-bit operating system now, the Windows API became it was kind of like at its height of popularity when Windows was inherently a 32-bit operating system. Like Microsoft redesigned the Windows API, and it was for 32-bit Windows, so they abbreviated it as Win32. Fast forward 25 years later, even though we don't use 32-bit computers anymore, the API is still commonly known as Win32. It's just sometimes that's the curse of coming up with a good name, is that the name sticks no matter what, even when it's not really relevant anymore. Anyway, so anytime you're writing a Win32 program, there are some basic things that you have to have, and you have to have a message loop in your main function. This message loop is going to just sit and run in a loop, and it's going to take the messages. The messages that a window receives are things like when you press a key, or whenever you press a mouse button, or even whenever you move the mouse, hover the mouse over the window. Every time you do that, Windows is sending hundreds and hundreds of messages to the application window and asking the application, hey, do you want to handle this message? Do you want to handle this message? Do you want to handle this message? And it's up to the programmer to program your own message loop that never hangs. It's important that it never hangs, because if your message loop hangs in any way, your entire application will lock up and it'll freeze, and it'll look like, if you've ever seen a hung application before and you try to click on it and nothing happens, and then it turns into sort of like a ghosted window, and that's what happens when your main message loop gets hung for some reason and fails to process window messages. Windows is sending you messages, but your application can't keep up, can't process them. It goes into a sort of like a catatonic state where it gets hung, and then you usually have to open up Task Manager and kill it. Okay, so number one, you need a message loop. Number two, you need what is called a callback. You need or actually a window procedure is what they call it. Window procedure, which it is a callback. It's basically saying, every time my window receives a message, I'm going to then dispatch that message, that window message, to my callback function. And that is where I am going to write all the logic myself to handle every one of those messages that Windows sends my way. So, let's see. So I think first I'm going to look up a Win32 apps. Yeah, this is another, like, notice it wants to send me to some C# stuff first. If I just look up WindProc, which is the abbreviation for window procedure, if I just look that up, notice how the documentation is always going to try to send you to some C++ or some mostly C# stuff first. Again, like I said in the first video, where because we're programming in C, we're kind of swimming upstream, we're kind of swimming against the current. This is yet another example. The documentation for the type of C code that we're writing is always going to be more sparse. Microsoft would prefer that you use C# or at least C++ and not C. Whatever. Let's just go. Let's forge ahead. Now this is what a window procedure looks like. And again, I'm probably just going to copy all this and paste it. But as you can see, here's our window proc, and it takes some inputs, and here's a switch, and for different types of window messages that come in, it does different things. And then that's all it does. It handles window messages. By the way, I'm one of those people that likes to highlight text as I'm talking, and I know that annoys some people, and I'm sorry, but that's just me. Anyway, I'm going to copy the entirety of this function, and I'm going to paste it right here. Okay, now one thing I like to do, let's fix this up a little bit. Actually, let's come back to it later. Okay. Now, the next thing we need is a message loop, right? So, let's see, while true. Now, we have just created an infinite loop because this while statement, it says, while this condition is true, I want you to run whatever is inside this block. And it won't stop running this code in a loop until this condition is no longer met. So when I specify a constant like true, true is equal to 1, where false is equal to 0, true is equal to 1, or basically, honestly, true is equal to anything that's not 0. If it's not 0, then it's true. If it's 0, then it's false. But anyway, this will always be true. Like, true is always true, right? It'll never change. Therefore, this code inside this while loop is going to continue looping forever and never stop. So we obviously need some sort of mechanism to allow us to break out of this loop, but for now, this is our first sort of stab at a message loop. So what we need to do is we need to dispatch, we'll get to all this stuff later. Nope. Oh, wait. No. Yeah. See, there's their with main. Here we go. Let's replace their message. Let's replace our message loop with their message loop. So you can see the error that we have here. It's because we don't have a variable MSG. So let's name this MSG message. And let's rename that message. And rename that message. And rename that message. Okay, so basically what this is saying while this get message function is greater than 0, then I want you to dispatch the message to our window procedure, whatever the window message is. And I want you to do that forever until the get message function returns something greater than 0, which probably means it failed or something like that. There's one other thing I want to do. I want to get away from all of these pound defined get message is defined as get message A. I would rather just put the A there, and that way I'm basically going around the pound defined. I just find it less confusing that way. So anytime you see something that's pound defined away into something else, it's basically obscured or abstracted into that, ASCII entry point versus Unicode entry point. Let's just go pure ASCII for right now. So I'll just put an A on the end, and now you can see that it's a real function once you get past that pound define. Okay, so this still isn't enough to actually get our program up and running yet. So see, we're almost at 45 minutes, so I think we can do this. Maybe. We need to do some things before this happens. We need to do some things. We need to register our window class, and we need to make a window. So when we register our window class, we're basically making a new type of window for Windows to show. And the thing to remember about programming in Windows is that everything is a window. And what I mean by that is when you think of a when you think of a traditional app, now, I mean, this may be programmed for, I don't think this is Win32 anymore. I think it's UWP, but let's just pretend it's Win32 for now. Calculator. What I mean by everything is a window is I mean this thing out here is a window, but also each one of these buttons individually is a window. That's what I mean. That's what I mean by everything is a window. So in other languages like C# WinForms, for example, you have all of these different classes. Every control that goes onto a window, you can slap a button onto a window. You can slap a drop-down menu onto a window. You can slap a list box down onto a window. All of these things have their own separate classes in another language such as C#. But in terms of Win32, if we're just programming it from scratch like this, it all at its most fundamental atomic level is a window. Everything starts as a window. So with that in mind, let's make a window. First thing we need to do is make a window class, which I'm going to fix this up later. But for now, I'm just going to copy someone else's code. Because, you know, it's just where we're at in life right now. Alright, so again, I'm going to, so if I hover over this, see it's green, it's type def to window class is what this stands for. Windows class EX means extended. This window class extended is type def to window class extended A, because once again we are set up to compile in ASCII mode. But to avoid all confusion, let's just make it a Windows class EX ASCII right off the bat. And I don't like little short variable names, so I'm going to spell it out. And I also don't like not initializing my local variables, so I'm going to initialize it like that. What this does is it basically sets this to all zeros. And I always like to set my local variables. I always like to initialize them first. I never like to leave them uninitialized. Let me show you what that means. I'm going to leave it uninitialized, and I'm going to run to cursor. I'm going to run, oh no. Let's actually comment out all of this stuff that we haven't gotten to yet. Comment out, comment out, comment out. Okay, let's try this one more time. Run to cursor. Okay, here we go. It is not running. All right, let's try this one more time. Run to cursor. Okay. It still didn't stop there. Some debug. Yeah, see, I don't know why I'm not able to hit this breakpoint. Because if I was on the release mode, I would expect to not hit this breakpoint, because window class, the compiler sees that we're never using window class, and therefore it would know to optimize it out, because we don't need it, so it won't even put it in the compiled executable. However, if we're on the debug version, I would not expect that to happen. I would expect this variable to still be here even though we're not using it. But since I know I'm using this one, let me try this one. Okay, it hit the breakpoint. So I'll have to figure out that thing with the this variable. It's like it got optimized out or something, but you can see I hit the breakpoint here on the message variable. If I go over here to, let's just add message to the watch window. We're watching the contents of the message variable, and as you can see, it's initialized to all 0x cc 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 cc, and this is something that the debug compiler does for you. It basically, if you're compiling for debug mode, it initializes all your variables for you to all C's. And the reason why it does that is because if you're debugging, it makes it easier to see what has been initialized and what hasn't if you're inspecting the memory like this. And also 0xcc just happens to be the it's no coincidence that they set it to all C's, because that also happens to be the opcode for int3, which is to a debug break. So if the CPU tries to execute this 0x, if the CPU tries to execute the 0xcc instruction, it's an automatic break into a debugger. So that's pretty cool. If we take one more step in our execution, you can see now in the watch window, because I have initialized it all to zeros, you can see down here that it is now all zeros. And you can see that the text is red. That means in Visual Studio, that means that this variable was just written to. It just got written to. That's why it's red. Now I'm going to stop it. In contrast, if we don't do that, let's try it again. If we don't initialize our local variable to 0, let's see what happens. You can see that it just basically skipped this part and it broke. It broke basically. It broke into the debugger at the next available opportunity. Even though I thought it was going to break here, it didn't, because this initialization never took place. It's still set to all C's. So let me stop this. And this actually isn't going the way that I wanted it to, because I want it's almost as if it's doing some optimization for me even in debug mode, and I don't particularly like that. So I may have to figure that out later. Let's see, C++. Optimization, disable. Inline functions, speed, neither. Program optimization, no. Okay, let's see if we can see the difference though. If we switch this over to release and then try it again. There, we broke into the debugger, and what is message? So if you look at message now, you can see that it contains essentially nonsense. Like, yeah, let's see. So, I don't know. I'll have to come up with a better example for that. It's not a very good learning example. So let's just, I'll come back to that later once I have a better example. This is essentially, these open brackets mean this is how you initialize a variable to all zeros when that variable is a data structure. That's a pretty important concept. For example, if I have just a regular integer variable and I want to initialize that to 0, then I can just type equals 0 and I don't have to put any brackets. But whenever I have a data structure, this data structure actually contains all sorts of stuff, like And so we'll use message as an example again. Let me make sure I'm back on debug. I'll use message as an example again. Even though message is a variable, notice how it expands to all these different things. Like there's a lot more data nested inside of it. That's called this is a data structure essentially, and we'll get to making our own data structures later, but this is just a built-in one that's part of Windows. And you can see it's not just an integer, it's not just a string, it's like a huge nested collection of data, and that's a data structure. They are hugely important, and like I said, we'll get to making our own data structures later. But that's how you initialize a data structure to all zero. It's basically saying whatever is inside this data structure, I want you to fill it with zeros. So it's essentially, it says however much memory this thing takes up. Say it takes up, let's say it takes up 16 bytes of memory is the total size of this data structure. Well, then I want you to write 16 bytes worth of zeros into memory wherever that data structure is in memory. Fill it with zeros. It's how you initialize it all to zeros. Okay, so let's we don't need that. We might need, let's go ahead and hwind, make this window handle. Okay. And I need to, we are going to now fill out this window class data structure. We're going to fill out the details of our window class. First thing I need to do though is I need to replace this WC with window class, because remember I renamed the variable. So just like that. And I like to double space everything. And there's no need to have it all cluttered. Alright. Got a couple more errors we need to take care of here. Okay, so the first thing, the first bit of detail that we're filling out about our window class is the size of it. And CB, I think, stands for the count in bytes of this data structure. It's very common in Windows. Is the first thing that you always fill out in your data structure is the size of that thing. So I'm going to change it just so that we're consistent here in our data types. So we have the same window class XEA, and this cool little guy right here gives you the size in bytes of it. And this is actually something else really cool. This is another cool trick that you can do. If I wanted to not have to fill that out, I could actually initialize my data structure as the size of that thing. And it would actually all work out, because instead of having to specify this extra line, I could just initialize it as that. You could do it either way. Anyway, I'll just leave it like that for now. The window class style, there's probably a whole bunch of window class styles you could put here. We'll probably manipulate that later. There's a very specific window style that we're going to need for this game, and that is, I want this window to essentially be full screen, borderless, so that it takes up the entire monitor. I don't want it to have minimize buttons and maximize buttons. I want it to take up the whole screen. So that's going to take some manipulation of these window styles. Alright, so the next thing that we fill out about this window class, it's asking us for a long pointer to a function, a long pointer to a window procedure function, which we already have our window procedure. We pasted it in earlier. We call it main wind proc, and I'm going to rename it because you know I like to rename everything. Main window proc. main window proc. I guess I'll leave it like that. Now this is going to be, I'm going to paste it right in here. Now it's going to say, I'll show you when we get there. There's going to be an error here, and I'll tell you why here in a minute. All right, so then we need to fill out some extra stuff, and I don't think those matter. I don't even remember what they are. It's asking us for a handle to the instance where this window class resides, and it's actually here. It resides here in our own program. So I can actually take this away because we are going to reference it. We are going to reference the instance parameter, and I'm going to put it right there. Okay, the next bit is it wants a handle to an icon, and I'm going to change that to icon A. The keyword null is just a 0. Null is 0, by the way. And that's basically a built-in Windows icon, is this application icon thing. We'll customize it later. It's just that you can have your own resources and you can customize your icon. We'll do all that later. Oh my goodness, we're already over an hour. I'm not going to be able to get the whole window loaded today, but anyway, let me finish this window class stuff. It's asking us for a handle to a background brush, which is like basically what color do you want it to be, and the color underscore window is like sort of that default gray Windows color. We'll just leave that alone for now. Menu name, so if you have like drop down menus like this, you might be using that, but we're not going to use that. It wants a long pointer to a string. SZ I think stands for, it basically means null terminated string. Class name, and it can be whatever you want it to be. We'll call it game. It does game B window class. We'll just name it that for now. And then finally, it's asking for a handle to a small icon, and again, we'll just load the small icon. Okay, and then finally, now that we've filled out all of the details about our window class, we have to register it. We have to register our window class with Windows. And let's see, window class. There we go. Now, this syntax where it's saying with this exclamation mark, it says, basically the exclamation mark means if this condition equals false. And remember earlier I said false always equals 0. So this function particularly is designed that if it fails, it will return 0. So if this function fails, if we fail to register this window class, it will return 0, which is a false, which means we will execute whatever is inside this if statement. Now, I actually don't prefer that syntax so much because it's so easy for your eyes to skip past that lone exclamation mark. Instead, I prefer to write it out like this. If it equals 0, if it returns 0, then, and by the way, if you copy that, paste it into here, and look at the documentation for it, always look at the documentation. What is your thing going to return? If the function fails, the return value is 0. To get extended information, call getLastError. So we are going to do that. So you always have to check the documentation and see what your function, the function that you're calling, what is it going to return. You can't always assume that they're going to follow the same convention. Sometimes they could return, they can fail, but they have different return values for failure. It might not always return 0. So what it's going to do is if we fail to register this window class, it's going to pop up a message box that says this failed, and then we're going to return. and that's the end of it. I think I'm going to eventually come back and change this and make the instrumentation a little bit better. One thing I hate is I hate it when it just says, you know, it failed, but it doesn't give me the error code. If you remember back on this documentation, it said call get last error. I want to do that. I want to call get last error and get the actual error code, and that way I can return the error code back to the user or the calling component. I hate just returning generic fail messages, and you lose that detail of like, well, what was the error code? Like, what actually failed? How did it fail? All right, we registered our window class. I'm going to keep going a little late here because I feel like we're getting really close. All right, so we registered our window class. The next thing we need to do is we need to create our window. To do that, I'm going to, remember I already made a variable for this way up here. So I'm going to copy it and I'm going to paste it right here. So we're now assigning a value to our window handle. This create window ex function returns a handle. And I'm going to put it all on one line. So the first parameter is like a window style. The next parameter is this class name. So you have to give it the name of the class, the window class that you just defined, which we just did. So I'm going to put that in there. The next thing is you need a title, and I'm just going to write window title. And then you have another window style thing over here, and then you have some positions. It looks like, do you want the window to show up in the center, or do you want it to show up over here in the corner, or you just want to use the window's default? And then you have a size, like what size do you want your window to be, and then you have some other parameters which probably aren't important. You have another instance over here, which is the instance of this executable. Is basically the instance that this window belongs to. And now that creates our window. So the next thing we're going to do is, if that window creation failed, then again we're going to display a message box that says it failed, and we're going to return. And now I think we're about ready to start. So we got a window class, we have a window, we have a message loop, we have a window proc that looks like it returns some stuff. Oh, and by the way, let me explain this window procedure a little bit. What it means is every time, again, like I said, every time a message comes in from Windows, we're going to dispatch the message. Dispatch message will dispatch the window message to the window class defined window procedure. So this is how we tied the two together right here. We said windows that belong to this window class, I want them to have this window procedure. That's how we tied those two together. And then this dispatch message, we'll look it up and he'll say, I'm dispatching the message to this window class, and it looks up what window procedure belongs to your window class, and it will run it right here. And what this does is it basically says what is the message that we just received. It might have been a create, it might have been a paint, it might have been a size, it might have been a destroy. It could have been any of these things. And then if it was none of those things, this is what we return by default. Default window procedure. So it's essentially saying any sort of window message that we want to handle, we can handle it and put in our own logic right here. But there are thousands of types of window messages, and you don't care about the vast majority of them. So for the ones that you don't care about, you let those fall through to the default window procedure, and it basically just passes them along to the next thing that processes the window messages that you didn't handle. Secondly, I'm going to hit tab right here because I don't like the way that these aren't indented. I feel like each case inside of a switch block should be indented, and yeah, I'm going to set this like that. All right, I think we're ready to run. Let's see what happens. Nope. Main window proc, undeclared identifier. Remember earlier I told you there was going to be an error. And the reason why is because when the compiler goes to compile this, it's literally reading the file from the top down. It's reading the file from the top down, and then it gets to here, and it doesn't know what main window proc is, even though we wrote main window proc down here. So it doesn't know what main window proc is here because main window proc is down below it. It hasn't gotten that far in parsing the C file yet. So what you can do is you can actually take the function, copy it. You can actually declare it up here, and I'm just cleaning it up a little bit. There. And semicolon. So this way we're basically declaring that, hey, somewhere else in this C file exists a function called main window proc. You don't have to define it here. You just have to declare it before you reference it. Now the compiler will know to go look elsewhere to find this function, and sure enough, it's down here. And it will work now because we basically pre-declared it. All right, so now if I hit play, let's go. Okay, so our program is running and our window is not being shown for whatever reason, and we're going to troubleshoot that on the next episode because we are completely out of time. So tune in next time, and the first thing that we should do next time is we'll have this window actually being displayed. So we're going to actually have something that resembles a Win32 app finally. All right, see y'all next time.